do I love and hate about software architecture and development? There is such a huge space to do things differently, and the result can be still valid. Or not? Software development isn't an exact science. It's a blend of science, engineering, craft, and art. Today, I will share my piece of art about managing RESTful APIs for all kinds of audiences. At the end of this video, you will be able to design your API for a simple front-end application as well as for an external partner or a public audience like Google does.
I say the magic words. Googly. Googly. Googly!
Let's dive in. Once upon a time, there was a castle that was isolated from the outer world. One day, a king declared,
"You must create an amazing castle courtyard to connect us with the people of the castle, and build a bridge to connect us with people from the outer world."
Do you see the parallel with our daily work? You have a backend application that contains logic and you have to create a courtyard, oh sorry, I meant API for your front-end application, and bridge to the castle, like API for external clients. But what does that mean? One backend and multiple APIs? Why and how to implement it? Don't worry, we will uncover everything a bit later. Creating a simple REST API is quite easy with existing framework and tools, right? But what about REST API for many external clients without possibility to do breaking changes? How to design an API for your amazing service and serve it to different kinds of consumers?
Very own consumers, the logger, the sweatshop foreman, the oil driller, the landmine developer.
Even I think that's kind of cruel.
I mean consumers like your internal front-end dev team, external partners with special requirements and customizations, and public audience of million independent developers. Let me just make a quick note. It looks like a situation where your API is consumed by different kinds of devices like mobile, web, smart TV and so on. This is typically solved by BFF. No, it's not
best friends forever,
but the backend for front-end pattern. However, our situation is different due to performance, security, customization and much more. Thus, it will be resolved differently. Stay tuned. API will die without an audience. It's important to know who consumes your data, and according to this, we distinguish the following types of APIs. Let's briefly describe the main kinds of RESTful APIs from an audience's perspective. Internal API. Internal API is typically consumed by front-end application or other internal application or services. The benefit is that you can relatively quickly evolve your API and closely communicate with another team.
Not so fast, please. Not so fast.
If you have the same release management, you can even change your endpoint without backward compatibility. But be very careful about this kind of changes. This must be communicated very well with other teams, and it must be an exception rather than the rule.
But love is the exception to every rule, is it not?
The point is that you can refactor your API in the similar way as your code and keep the API clean as much as possible. In the internal API approach, it's not always necessary to use API versioning, and sometimes it can be overkill and a productivity blocker in a smaller solution and audience. It may look like the internal API is not so important and that is possible to reduce the quality of the design or implementation. But on the contrary, the quality is important in all types of RESTful APIs.
Spend some holiday time.
Another thing I would like to point out is that you have to be careful in bigger and corporate environments. Although consumer teams are under the same hood, they work in different release management or communication is not smooth. As I mentioned before, in some big corporate projects, it's necessary to act with internal development teams in the same way as with an external. In that case, you have to use this partner API approach. This approach is not breaking change friendly, like an internal API. It's almost impossible to introduce breaking change because communication with all partners is so difficult, if not impossible.
Nothing's impossible, Albert. Impossible just takes a couple extra phone calls.
Because of that, the versioning is tool number 1 in your toolbox. A comprehensive and clear documentation is must-have, because communication with external partners is time-consuming and is multiplied by the number of partners. Sometimes effort and time spent on communication is similar or higher than integration itself. And finally, let's jump to the last type of RESTful API, public API. Public API and Partner API are very similar in implementation and rules. The main difference in the public API is that it's definitely not possible to communicate a breaking change in the same version of API with an audience. It's not possible to plan the release of your API and all consumers' applications at the same time. Moreover, you have to be very careful about any minor change because the way how your API is used by clients are so numerous and it's challenging to create a comprehensive impact study. I went through all the main well-known API categories. Each API type has different rules and ways of implementation, but the quality must be the same. There is no space for bad design. Now, you are able to distinguish types of RESTful APIs. Let's recap it and add a clear view of main differences. Internal API, only accessible within the organization. Often have a minimal documentation since developers can directly communicate with the team that built them. Specific intercompany security rules. High productivity. Possibility to allow breaking changes that only affect internal teams. Versioning is optional. Partner API, limited to specific authorized partners through contracts. More comprehensive and private documentation. Security typically uses API keys or OAuth with strict access controls. Changes are communicated directly to partners with longer deprecation periods. Breaking changes are almost impossible to communicate. And versioning is the must-have. Have negotiated rate limits based on partner agreements. And finally, public API, open to any developers who wants to use them. Require comprehensive, publicly available documentation. Use standardized authentication like OAuth or API keys with broad access management. Changes must be carefully managed with long deprecation periods to avoid breaking external apps. Expose only carefully designed public interfaces while protecting backend systems. Have strict rate limits and usage quotas, often tied to pricing tiers. And from a development perspective, these differences affect how you access and authenticate with the API, handle versioning and breaking changes, manage rate limits and quotas, find documentation and support, test and debug integrations. Wow, we are done with the boring theory and now let's dive into the secret of the implementation. Implementation of all API flavors.
And the cosmos is full of them.
We're finding all different flavors of hell, all these different ways that planets can go wrong. So that's where we are right now, searching for heaven, finding hell.
Close your eyes and imagine your amazing unique service or component without a public-facing interface. It's like a castle without a drawbridge. The service contains complex code and many internal methods and functions, and you would like to offer them to outer world. Our mission is to create multiple API layers, each for a given audience. In other words, we have to expose the same business logic via APIs for the front-end application, external partners, and public independent developers. Keep the situation in mind and let's implement it all API flavors step by step.
Step by step, with never a false move or moment of hesitation, he moves relentlessly toward another triumph.
Internal architecture of the service. As I mentioned before, you have an amazing piece of functionality and you have to propose the best way to expose it to the new front-end application, your B2B partners with some customization in mind, and all independent developers. We will talk about implementation of RESTful APIs without details about external architecture, infrastructure components like API management, and so on. If you would like to know more about these topics, just let me know and I will create a special video. Let's talk about the typical n-layered application from an API perspective. We have a domain layer. I really don't recommend exposing domain classes from your API. One exception can be enumerations that can be difficult and error-prone to manage in multiple places. I mean static enumeration like types and statuses. A typical example in the context of financial system can be contract type, contract status, product type, and more. But on the other hand, sharing this from the domain must be with caution. For example, a developer can rename it for an internal functionality implementation, and it will have impact on external clients.
Impact in 7, 6, 5.
Data layer typically contains mappings of domain classes to database for ORM, and it may contain DTOs, data transfer objects, that are useful mostly for effective communication with the UI or API layer. Application layer. There is nothing special from the API point of view. UI or API layer. This layer will be discussed during implementation of the particular type of API. API project structure. I will show you how to implement it in the Microsoft.NET n-layered application, but the same principles will apply in almost all possible technology stacks. It's really important to keep the system flexible for refactoring, changing and implementing new features without breaking the consumer's API clients. I am using something that I'm calling an API layer. This is a special place or folder in the application that contains request response objects, mapping, and orchestration for particular types of APIs. This layer is like a strict border between backend code for your developers and API interface for your API clients. Sounds like something complex and hard to implement?
It's so complex, isn't it?
Don't worry and let's jump to the code. I am used to creating a root folder in the API project where all types of APIs will sit. There can be internal, public, and others if it's necessary, like integration, customization, and so on. Another option is that the internal API sits in the root and others in the APIs folder. As you can see, there are folders for versions, endpoints or controllers if you are using MVC pattern, API models like request response object and mappings. Internal API. This type of API is used for internal consumers like front-end applications or other internal services. The typical requirement is fast implementation and delivery without unnecessary work. The simplest way to expose data is through ORM and domain classes, as you can see in the request model. but I don't definitely recommend it. If you go by this way, there is a very serious danger that each domain refactoring will destroy the consumer application. The mid solution is to create request and response classes that include or compose DTOs from the data layer. This approach is open for domain refactoring without affecting the consumer applications. Another benefit is that DTOs are possible to share for other APIs, but I will talk about that later.
Wait a minute. What's the matter? Wait a minute.
The most complex, safe and sometimes overkill solution is to create a request and response object with their own structure and properties without composing or sharing domain or DTO classes. This approach is good to use in projects where high quality is required without worry about time and development productivity.
With enough time and enough money, you could spend the rest of your life following the summer around the world. But for now, the endless summer must end.
Another reason is when implementation of the API client is done by an internal but isolated team with different release cycles. You can also consider using API versioning, which is optional for these kinds of APIs. Let's say that we chose the mid solution without versioning for our internal API. And now it's time to implement a partner API for the same service. Partner API. Imagine, we have a requirement from our B2B partner to expose our services. The partner wants to integrate their application with our service. We have at least two options. Either provide access to existing internal API or create a new one according to partner API type rules as we already discussed. I will just add that external communication with your API should be done by a reverse proxy, API gateway or API management. The most complex solution from the previous variants of the internal API plus versioning is the best way for creating a partner API. Public API. There is nothing special to show you, because public and partner APIs are very similar in terms of API design. You have to create special API endpoints or controllers, request-response objects, and mapping to your application layer object, like command or queries in case of CQRS. You have to be really careful about breaking changes, release management, documentation, and so on. Code reuse. In the previous chapter, we talked about API types and API layer. We have many entrances into our castle, but at the end of the journey are the same chambers. The situation in our application is very similar. There are special endpoints, request-response objects, and mappings for each type of API, like internal, partner, and public. But we have to use the same domain logic and probably a part of application logic as well, if the use case is the same or very similar. Let's assume that we are using some CQRS implementation with commands that sits in the application layer and queries mostly implemented in the data layer. We will implement our endpoint controller with these steps. Manually or automatically map request object into the command or query parameters or command or query itself. Execute the command or query. Map command or query result into the response object and HTTP status. If the endpoint in a different API layer is or will be more specialized, then you can create a special query or command without impacting other endpoints. Conclusion.
Conclusion inevitable. Unless.
The point of this video is that it's often better to create a special thin layer of API for a special audience. Sometimes it seems that the fastest solution is to offer your internal API for your front-end application to an external partner, but it mostly ends up with unhappy partners and internal teams as well. Development of the front-end application is slowed down, and partner's application is often broken because of internal changes. Another solution is to create an internal API with versioning and special request and response object for the front-end application and external partners as well. But the productivity of the internal teams is affected. As I mentioned in the beginning, software development is not an exact science, and what works for one project and team is not suitable for another. And what is your approach to exposing your application logic to multiple audience? Let me know in the comments.
I'll be outside. I'll be waiting. Just let me know.